Okay, here's the same chart that we just made, except it's prettied up a little bit. And now I've got my two equations. D equals 20 times 1.2, which I obviously got from this row right here. And the other one is D equals R times 0.8, which I got from right here. Now I've got a system of two equations, and I just have to solve it. Well, 20 times 1.2, can somebody do that in your head? I bet you can. Yes. 24, good. So D equals 24. And now I can do substitution. Wherever I see a D, I can put a 24. So I see a D right there, and I'm going to put a 24 there. 24 equals R times 0.8. See how easy it'll be to solve? All right, so I know the distance was 24, and since we were talking about miles per hour, that must be 24 what? Miles. And then my rate, when I divide by 0.8 here, my rate equals 30. And it must not be in like inches per second. It's got to be in the same units we were using before. So 30 miles per hour. Is it possible to ride a bike 30 miles per hour? It's probably yes, but he'd have to be riding really fast. But if he's really worried about his son up in a balloon, you get that super burst of adrenaline. Yeah, I could see him going 30. All right. So that's a good question. I didn't factor in how long you'd have to be riding that fast. All right. Fastest human, though, is supposed to be 22 miles per hour at top speed sprint. Okay, so you know you can bike faster than somebody riding or running at their top speed. So, all right, back to a new problem. What do you think I'm going to use to solve it? A chart. Would you please make me another chart in your notes? And above it, please label it with distance equals rate times time. It really helps you stay organized. And now I'm going to pause while you read this thing through once and try to make me a little sketch with arrows where people are going and stuff. Are they going towards each other, away from each other, at the same as each other, same direction as each other? Make me a little picture. Okay, so here's my picture. Minnetonka, train's heading that way. Duluth train, heading that way. They're going to end up hitting each other, right? I don't know how far either train went, but I know the total from here to here. What's that? 173.32 from there to there. See what I'm saying? So I don't know how far these are, but I know they add up to 173.32. Okay, so here's the Minnetonka train, here's the M train, and here's the Duluth train. So help me one step at a time. Did they specifically tell me how far the Minnetonka train went? No, they didn't say how far the Minnetonka train went. We know the two trains together went 173, but the Minnetonka train, I don't know, so I'm putting D. Do I know the rate at which the Minnetonka train is going? Yes, what is it? 55. And do I know the amount of time that it traveled before it hit? No. So I put a T. It's very simple for that top equation. I know one more thing. I know it on the bottom equation, I know the Duluth train is going 48. So that goes here. So now, this is where you earn your money, or where you earn your title of accelerated student. That box and that box. Those are the hard ones. All right. If I know the distance total is 173 about, and this is the part that the Minnetonka train did, then what did the Duluth train have to do? Yes. Yes. 173.32 minus D. Very good. Now, if that doesn't make sense to you, let me explain it this way. Would you agree that these two, this one and this one, have to add up to 173? You get that? I got to do that. So then I can test and see if I did it right. D plus 173.32 minus D has to equal 173.32. Does it? Yeah, because look, the D will cancel the negative D, and then it'll be true. 173.32 equals 173.32. So this little way of doing it where you start the chart with, if you don't know what it is, you just simply put a D here, like right there. That works great. It just leaves you extra. You got to do some work right in here. That's the hard part. Okay, same thing with the time. You got to think it through. Okay, if the time for the Minnetonka train, would the other train have traveled more time or less time or the same amount of time? They both left at the same time, right? So they keep chugging along until they hit each other, so they go the same amount of time. So what do I put there? T. There you go. And now you got a system of two equations. That's all there is to it. You just have to write the two equations out and solve it from there. So again, the two places you had to really think are here and here. All right, let's try another one. Oh, there's my answer. Forget that. Plane leaves Minneapolis traveling at blah, blah, blah. Okay, make me a quick sketch with the arrows, like which way these planes are going. Just a couple of arrow vectors. Okay, here's what I would have said. I got a plane leaving Minneapolis. Here's Minneapolis. And it's going 432. I don't really know where it's going, but I'm going to say it like that. Okay, at 432. And then I got another plane leaving Minneapolis also at the same time, but in the opposite direction. Aha. So my other little arrow goes like this. When will the planes be 500 miles apart? Oh, so from here to here is how far? 500. All right, so there's my little picture kind of what's going on. Just helps keep my brain organized. And now I have D equals R times T. And I make my little box just like this. And now I've got two planes. They're both from Minneapolis. I can't call them the Minneapolis planes. I'm just going to call them plane 1, P1, and P2. Plane 1, plane 2. Okay. Do I know how far plane 1 went? No, so I put D. That's a simple one. Do I know the rate plane 1 was going at? 432. Do I know how long the planes were flying before they got 500 miles apart? No. In fact, it even asks that. When will they be blah, blah, blah. So I don't know that, so I put D. So it's really simple. If you don't know it, you just put a letter. And now, let's do the bottom one. Let's put in the one thing we do know about the bottom one. What do we know about that one? 480. So I can put a 480 there. Remember how I said you're going to earn the big money for being able to answer that question and that question? Job employers don't really care that you can do the easy stuff because everybody can do the easy stuff. It's can you answer the hard stuff for you? All right, so now, the distance. Is the distance the same like it was last time? No, they aren't going to go the same distance. You know why? Because one's going at a faster rate. All right. So, what do I know about the distances, though? They're not the same, but they add up to 500. And so, therefore, what do I put here? Excellent. And if you wanted to check, this plus this would add up to 500. Okay. And then the time, the amount of time that they fly. Did they take off at the same time? Yes, and so then they must have flown for the same amount of time, right? So what do I put for the other T? Sorry, the other blank. T. All right, there it is. Now it's just system of equations, multiply it out, solve it. That's got to be the easy part. Don't know how to solve systems, you better go watch the old video on that. All right, so one last one. See if you can handle this one, setting it up all by yourself. And I'll check you in just a second. I'm going to hit this pause. So there's the start of my chart. I got Philly and Denver. And I'm going to see if I can fill it in. I'll pause while I fill it in because I don't have enough time. Okay, so there's all the stuff that's given. And now I just have to figure out two hard parts. Talk me through what you did for the Denver train when it comes to distance. Yes. Yep, because the Philly train plus the Denver train has to equal 1725. Good. And that's how you set that one up. Now all I have to do from here is write the equations. D equals 65T would be the first equation. And the bottom equation would be 1725 minus D equals 60 times T minus 3. And notice I put that in parentheses. It's really easy to just not have the parentheses and put the 60 times the t, but then you'd forget that you got to do 60 times t and 60 times the negative 3. Okay, so you got to have that in parentheses.